TEKS 2A, domain and range, continuous functions. So just like yesterday when we talked about discrete, now we're going to talk about continuous. So remember, we talked a little bit about this, that we said continuous is like, it's a graph where all the points are connected through a line. So all the points are connected through a line. So our domain and range are going to be a little different than discrete. So remember, on discrete, we listed all the x values for domain and we listed all the y values for range. So for this one, let's look at the example here. Notice I have two lines. So there's a red one and then there's a blue one. Your paper's in black and white, so just follow along up here to know which one's which. I'll go ahead and label this one A and this one B, and you can go ahead and do the same on your notes. That way you can know which one I'm talking about. So notice for the line on A, we have an open circle. So above the domain here, I'm going to make a little note that when we have the open circle, we're going to use the symbol less than. So when we have the open circle, we're going to use the symbol less than. When we have a closed circle, so a circle that's filled in, we're going to use less than or equal to. And then lastly, when we see an arrow, this tells us that it's either going to infinity, so like the positive direction, or negative infinity, the negative direction. So let's keep that in mind when we're looking at the graph on A. So for A, notice that we have an arrow right here, and we have the open circle. So that arrow, since it's going down, is going to represent negative infinity because it's going down. And this open circle, notice that point is at 1, 4. 1, 4. Okay. So now that we know this information, we can do the domain. And for the domain, we're always going to put the smallest number first. So I'm going to put small. Then we're going to choose a symbol, so either less than or equal to. Then we're going to choose X or Y, depending if it's domain or range. And then the other symbol, less than or equal to. And then the big number. Okay, so I'm going to change my color so we don't get confused on the actual work. Okay, so first it says the small number. So if we're looking at the domain, remember domain is the x's. So domain is going to either be, it's going to be this negative infinity and the 1, because those are both my x values. So negative infinity is smaller, so I'm going to write negative infinity. And since it has an arrow, I'm going to use the less than symbol. I forgot to write that up here. When we use the arrow, we use that less than symbol. So less than. Domain is x. And then since we have an open circle, this is going to be less than. And our x value here is 1. I'm going to write 1. So that's my answer for domain. So let's do the same for range, but now we're going to look at the y values. So again, my smallest number is still negative infinity. Less than y, because it's the range. Less than 4, because it's an open circle, and then my y value is 4. Okay. Let's look at the blue line where I labeled it B. So we're going to do the same thing. So I'm going to look at both points. So I have a closed circle here, and I have an arrow here. So this arrow, since it's going up, I'm going to say that's positive infinity. And this point right here is at 1, 0. So remember, this is going to be my x, and this is going to be my y. So if I'm looking at my smallest number, is my smallest number on the x's going to be 1 or infinity? So it's going to be 1. So I'm going to write 1, and since it's a closed dot, that's less than or equal to x, because x is the domain, less than infinity, because it has that arrow, and we know when we have the arrow, we use less than. Okay, same thing, we're going to look at range. So our smallest number on the y's is 0. Since it has a closed dot, that's going to be less than or equal to. Range is y, so I write a y. And that arrow is going to infinity, so I'm going to do less than infinity. So that is my domain and range for both graph A and graph B, where one has an open dot and the other one has a closed dot. Okay. Let's look at another example. This is our last example here. I just want to point out that if some of your papers got cut off, remember, just put it in your notebook and you can finish drawing the graph there. I think some of them got cut off where the closed dot is. Okay, so we're going to do the same thing. Notice that this one I have an open dot and I have a closed dot. So let's see what those points are. The point on the open dot is going to be -3, 8. -3, 8. The point on the closed dot is, it looks like, actually I think I made a little mistake here. Notice how this x-axis is going by 0.5s. See, 0.5, 1, 1.52. So this one is actually going to be -2.58. So -2.58. And this one over here where the closed dot is going to be +2.5, -8. Remember that the first number is x and the second number is y. Okay, so if we're looking at the domain, we're only looking at the x's. So what is smaller, -2.5 or +2.5? -2.5. So we're going to write -2.5. Since that -2.5 is on an open dot, that is going to be less than. Since we're dealing with domain, it's going to be x. And since the other one is a closed dot, it's going to be less than or equal to, and then that x value, which is 2.5. So that's our domain. Remember, it went small to big. Okay, we have one more. Let's look at our range. So our range is going to be our smallest y value. So we have 8 and we have -8. So our smallest y value is -8. Since that -8 is on a closed dot, that's going to be less than or equal to y because it's range. And then our +8 is on an open dot, so that's going to be less than 8. So that is our domain and range for this function.